Okay, I would like to welcome everyone to our presentation today, Envelope Solutions for Passive House Design. My name is Andreas Benzing. I am Executive Director of New Passive House. It is my pleasure to welcome Jason Cattelino, who is a technical consultant, and Jim Muhaw, who is an area manager Northeast with Rothoblaas USA. Both will present today Envelope Solutions that will provide airtightness and waterproofing strategies in passive house designs for low energy, healthy, comfortable, and durable buildings. I would like to thank Rothoblaas USA for being a sponsor and supporter of New Passive House. It really helps us to scale Passive House low carbon solutions and advance our industry here in New York. So without any further delay, I would like to welcome Jason and Jim, and please take it away.
My name is Jim Muhaw. As Andrea said, I'm the area sales manager for the Northeast, responsible for the area, the geographic area, basically from Washington, D.C. up through Maine and out to central Pennsylvania. Joining me is Jason Cattelino. Jason is our technical engineer that has recently joined us, has a background in structural engineering, especially in timber, and we're both going to be doing the presentation today. It's going to be formatted where I'm going to do a little bit of an introduction on slides as to who Rothoblaas is, and then we'll launch into our envelope solutions presentation, going through some of the basic concepts around passive house and focusing on membrane technologies that we have two of. And then Jason will pass it back to me about 3/4 of the way through, and I'll focus on tapes and gaskets and sealants and whatnot, and then close it up from there. So with that, Jason's going to be in command and control. So I'll have him go to the next slide. Most of you know, or those that don't know of us in Rothoblaas, we are based in northern Italy, in the very, very north. We're known for our solutions around timber construction. And we do a lot with concealed connectors and fasteners around there. We're a multinational company. We have subsidiaries. Each one of those blue dots represent a subsidiary where we operate, and you can see the footprint that we have, and we're growing. We have north of about 500 employees, and we have really thousands of products that we manage. And basically, Rothoblaas started out with Robert Blaas, focusing on really woodworking machinery, working out of the back of a van, old style. And during that time, it was running parallel to the innovations that were going on with engineered timber, so glulam and all the variants around that. And then he quickly migrated into fasteners and connectors, and then into air tightness and soundproofing. And we're growing to the extent where you can see the little picture of our building in Cortacci, Italy, in the very north. That is now a fully automated warehouse, all built out of mass timber. These are our product categories with fastening and concealed connectors. Everything, again, for timber construction to connect it together. We don't sell the wood. We leave that up to other people to do. We then focus on air tightness and waterproofing, which we'll be talking about today. We're doing a lot with acoustics, and we have a category of fall protection systems, lifelines and PPE. And then we also have tools and machinery. So Jason, I'm going to hand it off to you.
Yeah, sure. Thanks, Jim. Yeah, as Jim mentioned, I'm a technical consultant here at Rothoblaas. I'm located at our warehouse in Allentown, Pennsylvania, and I help with technical support all over the US, all states, and then also within Canada. So Jim kind of mentioned what we're going to be talking about today. So just again, listing here, I'm going to talk a little bit about air tightness and wind tightness, and then vapor diffusion and condensation and the risks that are associated with that. And then we'll go through some of our products, membranes and tapes, and Jim will help me with that. So with that, just going over the basic principles of passive house design, we have thermal insulation, windows and glazing, mechanical systems, air tightness, and thermal bridging. So here at Rothoblaas, we have solutions mainly for this air tightness and wind tightness of the building envelope. But we also have a couple products for sealing around penetrations and windows that'll help with the insulation as well. So we'll mainly focus on air tightness, wind tightness here today. Here's just a quick picture of some of the products that we offer. These are mainly for interior use of the building, and we'll go over a number of these products here briefly today. Obviously, we don't have time to go over everything, so we have a lot of good information in our catalogs and on our website as well. I have another image here just of the exterior of a structure, right? Some of the common products that we have. All right, so moving on to this concept of air tightness and wind tightness. So things that we need to consider, really the transfer of wind and air, vapor, heat, and also sound too through the building envelope. And we want to account for this in our design, and really the benefits of working through this in the design phase is occupant comfort, right? We have a controlled climate on the interior of the structure. As I mentioned, we're trying to reduce the transfer of noise and sound, right? So that also relates to our comfort. Overall indoor air quality, our risks of condensation and just moisture within our walls is significantly reduced, right? And any sort of condensation, that can translate to mold and even structural damage. And then also the energy efficiency side of things and how that plays into utility costs and overall maintenance costs. So airtight layers, this is really the interior of your structure, the interior layer, and it really prevents heat loss in the winter or entry of humid air from the summer coming into your structure, right? And it's really to control the vapor passage into your wall assembly. And there's a number of different ways that we can achieve this. Some are better than others, right? And I have a couple of examples there. Mainly, we're going to be focusing on membranes today because that's what we can offer for you, and definitely a good way to approach the design of these types of layers. If we look at wind tight layers, this is more the exterior of your building, and wind tight layers are similar but different, as many of you probably know. So these exterior layers really ensure the thermal efficiency of your structure. So you can have an insulated wall, right? But you put an outer shell on that and it just improves your thermal efficiency. And that's analogous to wearing a down coat and putting a shell over top of that, right? It just improves the warming capability there. This wind tight layer, it's also temporary protection during construction from both water and UV resistance from the elements of your structure. Can also be part of the permanent protection of your structure in the case of rain screens. But then it also acts as temporary protection if you do have some sort of failure within your siding or your cladding. And again, we'll be focusing on the membranes, although there's other ways that we can achieve this wind tight layer. So going on to moisture management and condensation, like two good reasons to regulate humidity and moisture within a structure is really avoid the risk of condensation. And again, that's really within the wall or roof assembly. That's where we're primarily concerned because that's where a lot of the damage can occur. And then also just the comfort of the occupants within the structure. So this should be a pretty well-known concept, but our wall or roof assembly, we can really think of it as a breathing, living thing, if you will, right? And of that assembly, we have vapor and heat that can be transferred and transmitted through all the elements there. Mainly what I'm going to be talking about today is structures within a cold climate where the vapor and heat drive is from the interior to the exterior, but that is obviously always, it's dependent on the climate and the location that you're at. So really we're talking about the principles of design, not necessarily the specific design here. So this concept of humidity, which most everyone should be well aware of, really the cooler that the temperature is, the less moisture that the air can hold. And so there's really two ways that we can see condensation. It's one, like I mentioned, right? The air is cooled to a dew point where that moisture has to escape, right? Or just the air becomes so saturated that there's no more vapor that can be held within that, right? So we can still have condensation at higher temperatures. We just typically see it at lower temperatures. So as I mentioned, we have a wall or roof assembly, and each component of that wall or roof assembly, it's characterized by resistance to vapor passage, right? This is our concept of vapor diffusion resistance, and that's really a property of the material and that component of the assembly. Okay, so here's just kind of basic general practices. Again, this is general for a cold climate. So we have the interior of our structure. Typically, we have a humid environment within the interior, generally speaking. So we want to keep moisture and humidity from entering into our wall assembly. And if it does, we want it to be able to escape that. So any exterior membranes or wind tight layer, we want that to be breathable so that moisture within that assembly can escape. Another thing to note here is that throughout that wall assembly, we're going to have differentials for moisture and for temperature too. So that all affects our risk of condensation. So we really have two types of condensation: this superficial condensation, which just occurs on the exterior of our wall assembly. Typically, this doesn't create structural damage, but it's obviously unsightly and something that we want to try to avoid. We also have interstitial condensation, and this is on the interior of our structure. And this is exactly what we're trying to avoid, because this is structural damage, very difficult to repair, and often we're not even aware that it's in the structure itself, right? So that's the danger of it. We have reduced structural capacity without knowing that it's even there, and that can cause failures. So any sort of moisture that's entering our wall assembly, this is just kind of a quick general graph and understanding of thermal conductivity. So if we see a 1% change in moisture content by volume for insulation, right, we see an increase in thermal conductivity by about 30%. So this just illustrates the point that it's very important that we try to control the moisture into that's going into our roof or wall assembly, because for more moisture, the higher the thermal conductivity, and that just means it's reducing our insulating efficiency. Okay, and then I talked about, previously the vapor transmission and this water vapor diffusion resistance. That's a material property of the specific material within our element. We're gonna mainly focus on US units here, but this SD value is a European unit, but some of you might be familiar with that. And this is really related to the perm value of a membrane, right? And so the water vapor diffusion resistance factor plays into what that value is. Okay, so classifying membranes. What's important to think about when we're selecting a membrane? I have a couple of examples here. What our mass per unit area is, and that relates to the overall durability. Also UV stability and aging, water tightness. If you have bulk water from rain or something on the construction site, that's different than water vapor or humidity transferring through that. Tensile strength, resistance, nail tearing. So a lot of different factors. Then obviously the vapor diffusion and passage of vapor through that. Also, fire class and fire rating performance is also important to think about too. So I'm going to go over the 3 classifications of membranes that we can offer. So really we can provide a solution for all types of construction and conditions, right? So the first that we'll go over, we offer barriers, and this is more like your typical true vapor barrier. It's a closed membrane that stops the passage of humidity and water vapor. And these are, again, for a cold climate, typically installed on the interior of the structure. So here's just example of the perm ratings of the barrier products that we offer. So less than 0.1 perm there that you can see, permeability. All of our barrier membranes, they're watertight against bulk water. They're provide airtight, wind tightness. And then, yeah, we don't have the breathability within these, where we're completely trying to stop the vapor transmission. Here's a couple of examples of barriers, right, and installed on either a roof assembly or a wall assembly there. And again, a number of different barrier products that we offer for specific applications. Okay, so yeah, what's important when we're trying to pick a membrane, and specifically a barrier product here? Obviously, the perm value, or the vapor, or the resistance to vapor passage. But then also, if there's any other special requirements, right? Does that membrane need to be transparent? Do you need to be able to see behind it for some sort of inspection? Does it need to be reflective to reflect different heat radiation, right? Like for say a sauna or something like that. I mentioned reaction to fire before. Sustainability, Jim is going to talk a little bit about that later on in the presentation. Is there a reinforcement mesh that's required? If you're doing a spray-in insulation, right? Sometimes we'll want to have a reinforced membrane just to help resist some of the push-out force of that. Obviously, the application is important, UV resistance, temperature resistance. So it all plays into what actual product is going to be specified. This picture in the lower right-hand corner is taken from our catalog, and it just shows some of the specific aspects of the membranes that we have, and it just shows the different characteristics. So it makes it a easy, quick selection. Okay, so moving on to the vapor stop layers, right? So this is very similar to the barrier membranes, but it does allow for some level of vapor transmission. It doesn't completely block that vapor transmission into the wall or roof assembly. So here's just the rating of some of the vapor membranes that we offer. So the question is, why would we select a vapor membrane over a barrier membrane? And it really just allows some sort of a factor of safety. So in some cases, yes, a barrier is required, but with a barrier membrane, the installation is extremely important. If there's an area where somebody misses the taping of a corner, and there's a small or there's a small penetration from one of the guys on site or something like that, you have this isolated area where your moisture and temperature is going to try to escape. So that can obviously cause isolated areas where you have a higher risk of condensation. So these vapor membranes provide a little factor of safety against that, and it just controls some sort of moisture movement through that envelope and through your wall or roof assembly. So again, here's a couple of examples of the products that we offer. Roof assembly and wall assembly. Okay, and then a special type of vapor membrane that we offer is called the Klima Control, and this is a variable permeability membrane. So it's really a smart membrane. Okay, and it acts as really both a vapor stop and a breathable membrane. Yeah, very similar to the vapor membranes here, but yes, it has a variable permeability rating, right? So as the moisture and condensation vapor build up on one side of your assembly or this membrane, it opens up and allows the passage of that vapor. Okay, and here's a couple, again, examples of that. Very popular membrane here, the Klima Control. Okay, and then when we're thinking about vapor stops and the Klima Control membranes, what are some other things that we should consider for these types of products? The mass per unit area, or kind of the overall durability. Is that variable permeability required? Right, that could be something that you actually need. Again, the application and other similar characteristics from what I talked about with the barrier, if it's transparent, reinforced, mesh. One other thing to add here, this at the end there, I have the versions, the TT, which is an integrated tape on the side of the membrane, right? So that saves time for the installation of the product on site, just making it easier to tape those joints. Okay, and then moving on to our Trasphere product, these are breathable membranes. These are typically on the outside, the cold side of your assembly. And they are, yes, they're breathable and they allow for the transmission of vapor. So if there is any sort of vapor or humidity within the wall or roof assembly, this will allow that to escape and just reduce the risk of any sort of condensation or mold growth within that. So yes, these are vapor open and allow for that passage. So a couple more examples here, and we'll mention this a little bit later on too, but all of these details and assemblies are available through our website, so you can go back and take a look at these. A couple other things to consider when selecting the Trasphere membranes. We have some that have a adhesive backing to it, so it's just a peel and stick. So there's no need for stapling or putting down any sort of adhesive or anything like that. We have one that's can be welded, either chemically or heat welded at the seams, so no need for tape for those products. We have another one that was specifically designed for under metal roofing, and that's for high temperature conditions, but then also just sound insulation too. And even some cases we can use that for more of an acoustic membrane for floor systems. We've done that before as well. Talking about the difference between the composition of some of our membranes, we have microporous membranes, and that's exactly what it sounds like. The functional film has micropores, and that's what allows the vapor to diffuse and transfer through those membranes. A microporous membrane, that functional film is mechanically attached to the upper and the lower layer there. And that differs from these monolithic membranes where it's a chemical reaction for the water to transfer through those membranes. And the monolithic membranes that we offer, we designate those with an EVO name. So just by kind of quickly looking through our products, you can easily identify which membranes are microporous versus monolithic. And you can see some of the comparisons here with thermal stability, durability, UV stability, and so on here. In general, monolithic membranes are better performing than microporous membranes. With that, there's usually a price increase a little bit, right? So something to consider for the project, but that doesn't mean that the microporous membranes are not a good solution for your project either. So just a couple things to consider there. Okay, and here's just a brief review of the membranes that I talked about. Again, we offer barriers that completely stop the passage of water vapor and humidity. We have vapor stop membranes and this Klima control, or the smart membrane that has variable permeability. And then we also have the vapor open Traspier membranes too. So just a couple tools to be aware of. These images come directly out of our catalog. Just recommendations for different membranes, interior, exterior of our wall or roof assembly in different climates. So these are pretty generalized in our catalog. I do have a link here within our presentation. I'm not going to pull it up here today for the sake of time, but on our website, we have a membrane selection tool that allows you to select different types of construction, from typical wood framing, wood construction, mass timber construction, which we're primarily selling connectors and screws for that. But then also, yeah, the application, whether it's a wall or a roof, and then the climate. And we have a lot of wall and roof assemblies there just for example and recommendations. So great tool there. When we're speaking again about just the general selection of a membrane, what are some of the variables in design, right? It's temperature, humidity, pressure within your structure, vapor diffusion resistance. And like I say, exactly, those are variables, right? They change over a period of time. So it's important, if we really want to look at the long-term performance of our structure, is to do an analysis over a period of time, right? And one of the software programs that you can do that is Woofy. So engineers here at Rothoblaas and technical consultants, including myself, we can assist with that dynamic analysis of the building envelope to help select the correct membrane for your specific application and climate. As I mentioned, there's full library of roof and wall assemblies and technical details that can be found on our website. These can also kind of be found from that previous link that I mentioned as well. And with that, I'm going to hand it off to Jim, and he'll talk about some tapes here and then some additional products.
Thanks, Jason. Appreciate it. Yeah, good job. Yeah, so I'm going to just spend some time, last few slides, on tapes and gaskets and sealants. First off is tapes. What's the anatomy of tapes? You have adhesive, which is the sticky stuff, of course, and then you have the reinforcing layer, and you have primer, and then support layer too. So those are it's the interplay that makes these tapes applicable in different conditions, whether it's windows or whether it's large stretches of membrane that you're connecting together. We have on our website, you can find this information through our catalog. There's different compatibility issues to be concerned about too. Rough material and the selection of tapes for those type of applications that you're taping to, the substrate, which sometimes in certain cases would need primer. Also, you want to consider whether or not the tape is going to be exposed to UV. So we have a chart that gives compatibility for all of our tapes that are available to what kind of substrate it's compatible with. So when you get into the adhesion and the cohesion of tapes, there's this interplay of dynamics that go on with the stickiness of the tape itself. Adhesion is essentially the way the stickiness of the backing of the tape, the actual stick. Cohesion is the actual kind of bonding of that adhesive to the substrate. So if you have a very rough surface, and if you have a very low viscosity adhesive, it may not seep into the nooks and crannies, and you may not get the strength that you need over time, as opposed to something that's very viscous, a more viscous type of adhesive that would seep into the little nooks and crannies of that substrate. So it's important to kind of understand, how these tapes are designed with the adhesive and the type of material that you're going to. Of course, all these tapes, it's best, probably all of the tape manufacturers recommend pressurizing tapes so that you get the best seal. And the more that you leave it set over time, the stronger it gets and the more cohesion that you get to the material, and very difficult to lift off. You also have mechanical resistance that you're assessing. There's characteristics of that, and long-term durability as far as UV resistance. Manufacturers, including us, will have specific UV resistant tapes that can be used on open joint rain screens. It's being popular with black membranes, getting that kind of design shadow line behind the rain screen. And then you have different various conditions that you're looking to as well. What tape is going to be best for what application? Are you taping around rafters on the outboard side, or are you taping on the inboard side? Are you taping your rough openings? Do you want a tape that has a little bit of stretch to it so that you can stretch it around certain corners? Or like on the bottom there, where you have the red and white tape, this tape is used for, it doesn't have any backing paper. When you pull it off the reel, it comes off basically like shipping tape, and you can do long stretches and be very efficient. So companies that are, their enterprise is to have panelized construction, they'll use this tape because it's very efficient to tape long stretches of membrane. We also see this tape used in CLT buildings where they're taping up, wood element to wood element in order to prevent, to address water mitigation. And then on the other side, you can see our UV resistant tapes. So just some of our types of tapes. Again, we have a tape that is highly adhesive, very durable tape called FlexiBand. That can be used, it's almost like our workhorse tape. It can be used inside, it can be used outside. It really can be used on a number of different substrates, and it's very durable. The Seal Band is a paper-based tape. Not all tapes are, the plastic type of backing, but they do use paper. And those are really convenient if you're doing a lot of detailing around certain, here in this beam connection. They have also on the back side of the tapes, there's split backs of different configurations, which can be very effective in window installations. And then again, the tape, which is a high efficiency application tape called Speedy Band, and then the UV tape called Front Band for UV applications where it's going to be exposed. And then there's a whole subset of tapes that are for windows. This is our plaster band kind of family of tapes. It's I guess we lost maybe a little bit of a marketing battle. Although these tapes can be plastered, they're really used for window applications. So these tapes are the ones that have the split backs. Some of them are vapor open, which allow moisture to pass through them. These tapes can also be looked at more or less like a membrane tape instead of the poly type based tapes. They can be very breathable and they're very durable in the window applications. We also have a flashing tape. That's one thing that you want to look at is the application and protecting of your sills and your rough opening, and the way that tape can cover that entire sill configuration, and the way that it can stretch around certain corners, etc. And then we also, to fill up the spaces between the rough opening and then the window frame itself, we have a unique spray-in foam that's called hermetic foam. That is actually a closed cell foam, which makes it, if you cut it, it still is airtight and watertight. It has great acoustic properties. It fills those gaps and it gives you some thermal, resistance there. And also, it's a foam that will actually expand and contract as your rough opening moves, as maybe the wood settles in. We'll also have gaskets around the perimeter of the window as well that are expanding gaskets. It's something to consider. A lot of folks, on project sites, you'll use other types of foams and gaskets that are really not compatible with the way the structure may move in the future. So this gives you a lot of flexibility, and they're forgiving, and they hold their airtightness and their waterproofness. And then we have a line of double-sided tapes in order to connect membranes to substrates. Some that is butyl-based, some that is just essentially like sticky stuff on both sides of the tape. They're really kind of handy in certain applications. There's also the consideration of glues, looking at adhesives in certain situations. Inside glue that has certain properties and certain values, and then there's inside glue, outside glue, and then there's glue for membranes, and then general profiles, as you could see maybe in the lower left-hand corner where they're taping a membrane to a window frame, and we have profiles for that application as well. Now we have also penetrations. Excuse me. We have different types of bituminous bands and foams and gaskets for around these type of penetrations. And we can also use our hermetic foam in these situations as well. So also, when you think about windows, and it's a whole classification that if you look at the way that windows are installed and how you address them. We address them, on the outside for wind tightness, and then for thermal conductivity, and then also for air tightness. And then also a component within that is the acoustic capabilities too. So there's all sorts of considerations with gaskets and foams and tapes in order to keep the window, the connection of the window to the main structure airtight and waterproof, and then have good acoustic values too, so that sound does not transmit through the open gaps. And just going through that again, there's some examples of a wind tight layer, looking at keeping the wind out, different types of profiles that you can use with split back tapes in the top right-hand corner, allowing easier installations, robust profiles again for sills. And there's lots of options that you can pick from. Also, one of the challenges is sealing outside corners of windows. This is a little protective kind of corner that you can use in rough openings of window frames. It's always a challenging area when you're at the ends at those corners. How do you address that? So we have these nifty little corners that make that job a lot easier instead of doing your origami through there. And then we have the addressing of thermal conductivity with windows, using again foams and gaskets and different types of applications, whether it's wood frame, whether it's masonry, etc. Expanding gaskets again, another example. Here on the left-hand side, in between the CLT panel and then the window frame itself, and then a number of different layers of profiles going up to protect the window that make sure it's waterproof properly. And then again, a little bit more on this hermetic foam. It is a closed cell, it is waterproof, it's airtight, and when you cut it, it stays that way, and it's forgiving as well. Airtight layers, different types of install capabilities of doing blind kind of install of tape around the perimeter of the window frame and then directly to the rough opening of the window to make a clean, connection between the window tape and then the outside frame. And then looking at different types of technical details. Again, as Jason said, there's a lot on our website that you can plug into and pull off to take a look at the different layers of these assemblies and what we recommend as a company for these window installations. One of the things that we've been doing a lot of as far as envelope is we don't sell or get involved with insulation. But what we do provide is specialty fasteners in this area. And it's an area that in the Northeast, we've been doing a lot of work with, looking at using specialty fasteners to do these connections of exterior insulation, both on the wall assemblies and then also on the roof assemblies. We also, Jason and I will do a technical recommendation as far as how long a screw do you need? What type of screw do you need? What's the configuration of the fastening pattern? There's wind loads or snow loads to be considered. It's the type of insulation, the squishiness, if you will, of the insulation does require different screws at different times so that it doesn't compress in the whole assembly move. There's shear resistance that we consider. But we have specialty screws that are double threaded screws. I don't know if you can make out on this image, but basically what we're creating is a truss, essentially a screw truss to house our insulation within this cavity. So these type of screws are embedded into these battens or these furring strips, and the threads actually create a moment connection, not allowing this batten to compress up against the structure. So it makes it a very, very rigid assembly in order to house the installations. So if there's projects out there that you'd like us to take a look at, please let us know. Mineral wool, wood fiber insulation, and all the variants we can work with. And when you also get involved with sticking screws through your airtight and your windproof layers, you want to consider specialty gaskets to self-seal around those screws. So there's gasket considerations behind those elements, the battens, and then the furring strips in order to seal around the screws going in, both on the wall and on the roof assembly as well. A lot of our membranes, and we're working to add more and more. We have our life cycle analysis that is posted on there. On our technical details, you can pull that information off. And you have your environmental declaration pages too, that you can pull your EPDs off there too. And a lot of our products are Passive House approved by the International Passive House Network, and that includes our climate control, a number of our tapes, and there's a few weather-resistant barriers in there too that are Passive House approved. So you can take a look and you can see all of those capabilities there. And actually, thanks, Jason. This is the list of all the EPDMs that we have, and then some of the life cycle analysis that we have for our membranes. So you can pull them off there. Certified tapes by Passive House, Workhorse black and white tape, FlexiBand, Speedy Band, which is that tape that you can do long stretches with, and then the Seal Band, which is our interior tape that we use. And then also the climate control. So that's the end of the presentation. I think Andreas might have some questions for us. That's our motto, more wood, less CO2. If you're ever in Northern Italy, please let us know. We host tours there. We also we are promoting our Rothoblaas professional school with courses. You can go to our website and see some of the courses that are being presented, and hopefully in the near future, we'll be bringing that to the US, where everybody here would be a little easier for folks to participate one-on-one. So that's it.
Thanks, Jim and Jason, for the presentation. It was
sure.
Great. Some building science here, and also to see that membranes and tapes become quite high-tech, right, in order to achieve our goal of low operational carbon. And it's great to see that you guys think about the embodied carbon as well in your products. So we have a couple of questions here, and if you have questions, just please place them into the chat box. We'll take them. One question was, is the climate control membrane self-sealing?
It's not self-sealing like a self-adhesive membrane would be. We do have to tape all the connections. You don't have to tape over your staples and whatnot, but there's always that that good, better, best, and then bomber. So we do have folks addressing sometimes staples, but it's not standard recommendation.
Mhm. And I mean, you offer a lot of different membranes and also very specific tapes for different situations. One question is by Chris. He asks, do you still need water dams at the sill with your tapes and membranes?
Water dams, like I guess he's talking, Andreas, about maybe a flashing pan. Is that what?
Yeah, a kind of
Yeah,
pen, or you build a dam behind your window on the sill.
yeah. Jason, I don't know if you have a comment about that. But my personal opinion is yes, you can always do more with waterproofing, to add additional things. These are protective layers under maybe a flashing that goes over the top of it. And we run these profiles up the frame of the window, and then also up onto the window front of the window as well, to really get multiple redundant layers.
Mm-hmm.
So I don't know if
Yeah,
I answered the question.
yeah, I don't think I have anything to add to that right now, Jim.
Also,
Yeah.
I think the pen, or a water dam is more related probably to your window you choose, right? Depending, I know that European windows are often used to install it without a pen, but I think we are used to install them with pen. But I think that depends on your design detail and specifically the window itself. There's another question: what is the expected lifespan of your products?
Yeah, I think that's obviously a general question, and it's going to depend on the product, whether it's a membrane or a tape or a gasket, right? So if there's something specifically, I don't know everything off the top of my head here, so I'd have to look into it. But yeah, if there's a specific product, let us know, and then we can look into it.
There's one more question regarding airtightness of the building and how sealing of the building envelope potentially increases the indoor air quality and kind of moisture control of the space.
Yeah, and that'll be specific to your project, and obviously the application that you're looking, and if you're looking at a wall assembly versus a roof assembly, and then yeah, just whatever the level of humidity is within the structure and what climate you're in. So there's a lot of factors there, and yeah, those are all inputs into your analysis of the structure, right? And then you're trying to assess the risk of mold, and that's something that we can do through different software platforms like this Woofy, and there's others that are available out there too. So yeah, it's specific to the project, but yes, something very important that you need to address in your design, because yeah, we obviously don't want mold growth. And through that analysis, we can get a very good result and approximation of how that assembly is going to behave, and we can just evaluate what the risk is.
Mm-hmm. Do you provide Wolfie analysis for, so if someone has a specific detail of wall assembly with your membrane and products, do you provide a Wolfie analysis for that specific wall detail?
Yeah, we do have the program and the capability. Myself, I can run that analysis. That we have some of my colleagues that are over at our headquarters are more experienced with that than I am. But yes, if there's a specific question and application, we can assist with that analysis.
Mm-hmm.
Very good. Do you have also specific products for hot and humid climates? You mentioned that you have cold climate, or you spoke more about the cold climate.
Yeah. If you go into that the technical area where you look at the envelope solutions. You know, in cold climates, we'll be more concerned about the vapor being on the inside. On humid, hot climates, we want to put that vapor barrier, that control barrier on the outside. So it just reverses, right? So we do have those general kind of recommendations, you know, on our website. And you know, again, that's you know, here we are in New York, you know, approaching 90 degrees for several days, and then across the world, I think it's something we're going to be addressing a little bit more in the future. But yeah, we have the capability of looking at it from a hot, humid point of view, and looking at you know, what's the best assembly in Louisiana, you know, type thing. So so we can do that. You know, and when you get into Jason and I have recently been working on I wouldn't say it's an industrial building, but a production building that is going to be a hard cider manufacturer. And you know, there's lots of humidity that's coming from the manufacturing of that. So how do we address that? When's that going to happen? You know, what time of year is all that vapor going to be entering into this building, and how does that dry out? How does that impact the whole assembly? And it gets, you know, it gets complicated quick, right?
And a
So
swimming pool would be another good example, right, for managing moisture in a high performance building. How would you handle like mixed climate like New York?
you know, it's you know, we see a lot of folks using the variable permeability membranes, you know, and just a vapor open assembly as far as on the outboard side. You know, that's generally the kind of the go-to assembly. It's when you get into those extreme climates, right? Either very moist and very, you know, very humid and very hot environments. You know, in very hot, dry environments, we have a reflective membrane that is put on the outside of the building to reflect heat to the outside. We've had some folks in Texas consider that. Although you reverse it, and if you're in Siberia or northern Canada, you would put it on the inside. So you know, it changes. But in a climate that's you know, mixed climate, DC up through, you know, the Northeast, we see that general assembly of, you know, the variable permeability clima membranes being used with just a vapor open type of waterproof, wind tight, and a secondary air barrier membrane.
And so maybe a final question, how do we get those products and how long does it take when we order?
Well, our base of operations that I should have mentioned in our introduction, we recently, just as of the first of the year, established our warehouse, and it's developing into our base of operations, which is where Jason is right now, is in Allentown, Pennsylvania. So we're uniquely situated close to the Eastern Seaboard, so that for the, you know, while we're bringing in, you know, material from Europe, you know, it's our plans to do more in the US as far as manufacturing. But our base of operations and our warehouse is in Allentown, Pennsylvania. So within days, we can get it to you guys in New York, probably within a day or so. And we continue to evolve that our operations there to bring more and more products on board. And yeah, hopefully as we grow, we will grow as well with our warehouse capability to get you more options. So love to work with everybody and get recommendations from you as what we need to do.
Absolutely, yeah. So thanks for the presentation. It was great to see that technical expertise and the solutions you guys offer. It's great to have that. And so if you have further questions, more detailed or product questions, please don't hesitate to connect with Jim and Jason. We'll send out the recording and also the contact infos. So thanks, guys.
Thanks, Andreas.
Great.
Thanks, everybody. Have a
Thank
great
you,
afternoon.
everyone.
All right,
Thank
stay
you.
cool. All right, bye-bye.